What's up everyone, and welcome to another video. Today the main focus is on hyperbolic function. So first of all, we got the equation of hyperbolic function, which is as follows: y is equal to a over x plus p plus q. Okay, when a is greater than 0, the hyperbola lies in the first and third quadrants. As you can see, one arm lies in the first quadrant and the other in the third quadrant. The graph decreases for all x less than 0 or x greater than 0, which means this is a decreasing function. So the graph decreases for all real numbers when a is greater than 0. It decreases for all real numbers when a is greater than 0, which means when a is positive. Now, when a is less than 0, the hyperbola lies in the second and fourth quadrant. As you can see here, one arm is in the second quadrant and the other is in the fourth quadrant. Moving on, the graph increases for all x less than 0 or x greater than 0, which means this graph is an increasing function. It means that this graph increases for all real numbers, x values. Okay, all x values, not real numbers, but all x values. Now, parameters p and q. We move on. We got the parameters p and q. Q shifts the graph up or down. P shifts the graph left or right. When p is greater than 0, the graph shifts left. When p is less than 0, the graph shifts right. And you already know this from parabola, so we can move on to the next part. Now we're gonna talk about the equations of the asymptotes. Okay, we're gonna talk about the equations of the asymptotes. Y is equal to q is the horizontal asymptote, and x is equal to p is the vertical asymptote. Now, as I've shown here on this equation, q is the horizontal asymptote and p is the vertical asymptote. For example, we have y is equal to 3 over x minus 4 plus 6. The vertical asymptote, the horizontal asymptote is y is equal to 6, which is this value over there, that's q. And then the vertical asymptote is x is equal to 4. So all you do, you just pretend that you have x minus 4 and you equate it to 0, then you take 4 to the other side, and that's your vertical asymptote. You can also do the same for the previous parabola, for the turning point. Okay, the turning point of the graph, the p value, the value of p, you can just pretend that you equate the whole thing. For example, x plus 5 is equal to 0, you take it to the other side, and that's the value of p on the graph. Now moving on, domain and range. Domain, x is equal to x is the element of all real numbers, but x cannot be equal to p. Then the range is y is the element of all real numbers, but y cannot be equal to q. So I got an example here. Y is equal to 3 over x minus 4 plus 6. The domain is x is the element of all real numbers, but x cannot be equal to 4. Now remember what I said, pretend that you equate this to 0 in order to get the domain or the vertical asymptote. Now moving on, the range is y is the element of all real numbers, but y cannot be equal to 6. Okay, and then we move on. Axis of symmetry. So the axis of symmetry for this graph, the hyperbolic function, these are two lines passing through the points of intersection of the asymptotes. These are two lines passing through the points of intersection of the asymptotes. Okay. So what this means is these are two straight lines passing through the point of intersection of the asymptotes. The point of intersection of the two asymptotes is going to be p is to q. P is to q is the point of intersection of the asymptotes, and it's found, for example, in this equation. This and that is the point of intersection of of a hyperbolic function. So you'd write it like this. When you're writing the coordinates of the turning point of the point of intersection of the asymptotes, you'd write it like this. For this graph, you'd write it as 4:6, like that. Okay, so first one, we have the one with the positive gradient, y is equal to mx plus c. Note that m is always equals to 1, no matter what. M is always equal to 1. So if if m is always equal to 1, then that means the equation for this line would be y is equal to x plus c. Okay, so you'd substitute a point from the graph. You substitute a point that from the graph, from your hyperbolic function graph, into this equation to find its equation. 4:6 right there. You're gonna sub 4:6 right there. So what I'm saying is you substitute the point of intersection of the asymptotes to get the equation of this line. So let's just do it now. Let's find the equation for this one. So the equation for the equation of the line passing through the point of intersection of this one, basically the axial symmetry with the positive gradient for this equation here would be, okay, so let's just skip to subbing. So you would sub 4:6, therefore it would be 6 is equal to x, 4, right, 4 here plus c, then therefore c would be 6 minus 4, that's 2. Therefore the equation for this graph, for this line, the axial symmetry, the positive gradient would be y is equal to x plus 2, like that. You do the same for this following one, which is the one with the negative gradient, which is y is equal to negative mx plus c. M is always -1 for this one because it has a negative gradient. Then you sub the point of intersection of the asymptotes and find its equation easily, like that. So yeah, that is the end of this video. See you guys in the next one.